Hello. In question 10, we're going to go over some eigenvalue and eigenvector practice. Now, to find the eigenvalues of a matrix, and this is our first step, we have to find the values of lambda that satisfy this equation. Determinant of A minus lambda I equals 0, or determinant of 5, 3, negative 1, 1, minus lambda 0, 0, lambda, because I, in this case, is the identity matrix. Now we can just simplify this. Determinant of 5 minus lambda, 3, negative 1, 1 minus lambda, equals 0. Honestly, I would just skip to the third step when you write out your work, just to save time. But now we solve for the determinant of a 2 by 2 matrix. So we take the diagonals and we do the thing. So 5 is lambda, 1 minus lambda, do that, minus the product of the upper diagonal, so negative 3 equals 0. We calculate this out, so I believe this becomes lambda squared minus 6 lambda minus, plus 5 plus 3 equals 0. And I believe, so this is 8, so that would factor lambda minus 2, lambda minus 4, so we get lambda equals 2, lambda equals 4. So these are our eigenvalues. It's good that we have 2 here. All right, now that we have our eigenvalues, we can find our eigenvectors. Eigenvectors are the way you find them is you take A times, or no, I believe it's A minus lambda I times Vi equals 0 vector. And so you're solving, in this case, for V sub I. And what we're going to do first is we're going to label our eigenvalues. Now, it doesn't actually matter the order you label them in, but for other things in the future that we might end up doing, you should label them in descending order. So our first one, lambda 1, is going to equal 4. And our second eigenvalue, lambda 2, is going to equal our lower value, which is 2. All right, so for lambda 1, we're going to solve. So we take, this is A minus 4I equals 0. Or, sorry, forgot the vector. So we plug them in. 1, 3, negative 1, negative 3, times V1 equals 0. Now, in this case, you're going to have to find the vector V that when you dot it with A, you get the 0 vector. In this case, I think it's rather obvious that V equals 1, negative 1, or you could say it equals negative 1, 1. They're both pretty much equivalent in this case. So let's just say this is our first eigenvector. And for our second eigenvector, we're going to plug in lambda 2. So we're going to do the exact same thing, plug in 2 instead of 4. So we get 3, 3, negative 1, times V1. I am now realizing that I have made a grave mistake in the first calculation. So V1 does not equal that. That's what V2 equals. V2 equals negative 1, 1. And V1 equals, looks like negative 3, 1. Yeah. So those are our 2 eigenvalues. Sorry about that. And some last notes. In this case, we only had a 2 by 2 matrix, but if you were, say, given a 3 by 3 matrix, we would expect you to calculate the determinants by hand and then solve. Additionally, some matrices do not have a full complement of eigenvalues. So for instance, you might have like a 3 by 3 matrix with only 2 eigenvalues. That can happen. Don't panic if you see it. All right. Good luck on your studying.